Just to prove that there's absolutely nothing up my sleeve, you can see at the top of this screen that router 3 has the loopback 3333 created, 32-bit mask, a host mask that is, and just to verify there's interface loopback 0, and on router 1 we have a loopback 0 as well, IP address 1111 with a host mask. So let's proceed now and get that adjacency back up and running. We're going to take it one step at a time and put one command on router 1 and then the corresponding one on 3 so we can keep checking the adjacencies. And right now let's go with the remote AS command. Nice try. So we're putting 333 in this time and then remote AS 200. And we'll just give that a moment, and I'll run show IP BGP sum on this side. Just want to get you used to seeing the different stages. There's idle for a state, so nothing much happening here yet. Let's go over to 3. And let's see. Pardon me. BGP summary. And you can see, I'll have to move this one over just a little bit, but you can see the state of idle over there all the way on the right-hand side. So even though last time, we did the peering between 1 and 3, this is all we had to do. But we weren't using loopbacks, we were using the physical interfaces that were on the same subnet, so we were able to just go right ahead and use the neighbor command, and that was that. Now we need an eBGP multi-hop command. And just for the sake of foolish consistency, I will start on router 1, and let's have a look for that command. And there it is right in the middle. eBGP multi-hop allows eBGP neighbors not on directly connected networks, and we are working with eBGP here. So, gotta get that tricky little dash in. And just one, please. Multi-hop. And you do have a value of 1 through 255. It's a good habit to get into keeping these values as low as possible while still getting the job done. It's also a good habit for Cisco exams because they tend to ask you that kind of thing. And 2, right here, my friend, will do the job. So let's go over to router 3, put that same corresponding command in. And now we've got that set up. Let's run show eBGP sum. And we're still kind of sitting here. We're sitting here kind of idle. Let's see what router 1 says. Router 1 says it's active, so we got something going on in there. We went over all these states earlier, but we know, just like with EIGRP, we don't want this to stay active. We want it to go to established. That's what we're looking for. So now we're going to use our update source command, and we'll do a conf t router BGP 100. And this one's, as you would expect, since it begins with U, is all the way at the bottom, source of routing update. So we're going to say update source, and then you just put the physical interface. Notice that it's not asking anywhere here for an IP address, so we need to go ahead and put loopback 0, and that's where they're coming from. And in 3, we're going to put pretty much the same command. Update sour loopback 0. And so we've got our 3 commands here for neighbors when we're using loopbacks and we have an eBGP relationship going on, or peering that we want to have going on. We've got the remote AS command, we got eBGP multi-hop, we got update source, and we still have an incredibly idle situation. Let's go over to router 1, and I think we're going to see active. Maybe, yep, still active. So everybody involved is trying, but of course we know what the issue is. We discussed it at the end of the last video, and this is where static routing comes in. Because router 1 doesn't have the faintest idea where the IP address 3333 is. Router 3 doesn't have any way of knowing where 1111 is, so we could work in a routing protocol here, a dynamic IGP, but instead we're going to go ahead and use a static route. It's good practice too, because it might have been a while since you made a static route. What comes next? Pop quiz, what comes next? We're going to put the address in, and since we're going to make this a host route, which matches only one address, what am I putting next? Is it all 1s or all 0s? That one is going to be all zeros. It's a prefix mask. And then you could put either the next hop IP address, which I prefer to do, or the local exit interface. I'm going to put 172.12.123.3. Then I'm going to go over to 3 and put in a mirror, if you will, to 1111. 12.123.1. And boy, that didn't take long. And there you go. That's so easy to overlook. You'll never overlook it, exam or production or lab, once you see it, but it's so easy because, you know, you're just so consumed with the new commands. And you keep looking, it's like, okay, I got the right remote AS, I got the right neighbor, I got eBGP multi-hop, I got update source, etc., etc. But you just needed to remember that 1's got to know where that remote loopback is, and 3 needed to know where router 1's loopback was. So let's go ahead and check out our situation on router 1, just in case. And that is what we like to see. Now we've got our neighbor adjacencies back. Notice now that the neighbor is 3333, not 172.12.123.3, as we had before, and everything else looks exactly the same. So we are done there. Coming up next, we are going to advertise our first routes in BGP using the lab that we have built to this point. I'll see you on the next video.